All right, reflections. Reflections are a flip or a fold over a line of reflection. This is a flip, or you can think of it as a fold over a line of reflection. It does not preserve orientation. When we are reflecting across an axis, across the x-axis or across the y-axis, we've got some general rules that we can use. If we are going across the x-axis, then the x will stay the same. And the y will change signs. X will stay the same, y will change signs. Again, this is when we're going across the x-axis. I'm going to pass out some straight edges. Yes. Can you see the words at all? Barely. All right, I'll see what I can do. All right, we need to come up with the ordered pairs for points C and D, and then we will use those to determine the ordered pairs for C prime and D prime. What is the ordered pair right now for where point C is? Negative 5, 7. C is negative 5, 7. So if we're reflecting across the x-axis, the x stays the same. So for C prime, x is still negative 5. But the y changes signs. So what is y going to be here? Negative 7. So negative 5, negative 7. Negative 5, negative 7 would be right here. That's our point C prime. What is the ordered pair for point D right now? Negative 3, 1. So what would be the ordered pair for D prime then? Negative 3, negative 1. Negative 3, negative 1 would be right here. We're going to label that as D prime. And then we're going to grab a straight edge and we're going to connect C prime to D prime. It's in the back, but you can sit by J back there. That puts you a little closer to the board. All right. Let's look at number 2 now. Number 2, we're going to reflect across the y-axis instead of across the x-axis. So if we reflect across x, and that means x stays the same and y changes signs, what do you think it's going to look like when we reflect across the y-axis? Yes, y stays the same and x changes signs. So let's write down the ordered pairs for G, F, and H first. Here's G, F, and H. What's the ordered pair for G? negative 5, 6. What's the ordered pair for F? 4, 5. And the ordered pair for H? 2, 1. We are going to reflect this across the y-axis. So on all of these, the x will change sign, but y will stay the same. So G prime would become positive 5, 6. F prime would become negative 4, 5. And H prime becomes negative 2, 1. So now let's go plot those points. 5, 6 puts my point G prime right here. Negative 4, 5 puts my point F prime right here. And negative 2, 1 puts my point H prime right here. And then I grab a straight edge and I connect those points. And if you look carefully, it looks like we have taken the original triangle and flipped it over this y-axis. This is the reflection that's happened here. All right. Nicely done so far. Let's go look at number 3. Consider triangle HIJ with vertices negative 8, negative 7 for H, negative 6, negative 1 for I, and negative 3, negative 5 for J. Very first thing we're going to do is graph triangle HIJ. So I need a point at negative 8, negative 7. Right here. There's H. Negative 6, negative 1. Right here. For I. Negative 3, negative 5 right here. For J. And then we're going to connect those points together. Now we're going to take all of those points, we're going to reflect across the y-axis. Whatever axis we are going over stays the same. So if we're reflecting across the y-axis, then y stays the same, and x will change signs. So what will H prime be then? Y stays the same, x changes signs. We have our ordered pairs written down up here. What will H prime be? 8, negative 7. What about I prime? 6, negative 1. And J prime? 3, negative 5. So we're going to go plot all of those points. 8, negative 7. Right here is H prime. 6, negative 1. Right here. For I prime. And 3, negative 5. Right here. For J prime. Grab the straight edge and connect those points to make the reflected triangle. This triangle has flipped over, has reflected over the y-axis. Now we're going to take all of those points that we just reflected. We're going to take triangle H prime, I prime, J prime, and we're going to reflect it across the x-axis. So now x will stay the same, and y will change signs. So if H prime is 8, negative 7, what will H double prime be? Eight, 7. What about I double prime? 6, 1. And J double prime? 3, 5. Yes. The X's all stayed positive. 8, 6, 3. 8, 6, 3. But the Y's all changed signs. They were all negative over here, so they're all positive over here. So let's go plot those points then. 8, 7. Right here for H double prime. 6, 1. Right here for I double prime. And 3, 5 right here for J double prime. And we grab our straight edge and we connect those points to make a reflected triangle. So we took the green one and we flipped it over this way, like this. All right. Nicely done. Are you guys ready to look at the bottom of the page now? So far we've reflected over axes, the x-axis and the y-axis, and the way we remember how to do that, the tools that we use, the trick or the formula, if you want to think about it that way, is whatever axis we are going over stays the same. The other part of the ordered pair would change signs. If we are going across a line that is not an axis, like right here, we're going to go across the line y equals -2. This is a vertical line. This is going to go through the x-axis at -2. Goes through the x-axis at -2. So I go find -2 on the x-axis. That's right here. And I'm going to do a dotted vertical line through that point. Dotted vertical line through that point. Do it a little bit better. There we go. This is x equals -2. When we go across a line that is not an axis, I don't have a formula like we do when I go over the x-axis or go over the y-axis. What we're going to have to do is count. If I'm reflecting across a vertical line like this, I'm going to count how far is it from my points to that line, and then I'm going to go the same distance away on the other side. So for example, if I wanted to move point M here, I want to reflect point M. How many hops would it take for me to get from M to this line? 2. 1, 2. So now I'm going to go 2 hops on the other side. 1, 2. And I'm going to put down my point. There's my M prime. 2 hops to get to the line, so 2 hops on the other side. So what is the ordered pair then for M prime? -4, -1 is absolutely correct. We're going to do the same thing for N. We're going to figure out how many hops to get to the line, then we're going to go that many hops on the other side. So I go 1, 2, 3, 4, 5, 6, 7, 8 hops to get to the line. So 1, 2, 3, 4, 5, 6, 7, 8 hops on the other side. And I put down my point for n prime. Where did n prime end up at? -10, -2, yes. Then the same thing for O. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 hops to get to the line. So 1, 2, 3, 4, 5, 6, 7, 8. I need to go 1 hop past my graph, just a little bit past my graph to get O prime. What would the coordinates of O prime be? -11, -6. And then we're going to connect those dots together using our straight edge to make the reflected triangle. And when you get done with your reflected triangle, it should look like you took the original one and flipped or folded it over this vertical line. All right. Number 5, last one on this page. We're going to reflect across the line y equals 2. If x equals -2 is a vertical line, what kind of line would y equals 2 be? Horizontal line. This is a horizontal line through the y-axis at 2. So I'm going to find 2 on the y-axis. That's right here. And I'm going to draw a horizontal dashed line through that point. This is y equals 2. They did not have anything graphed on here for me originally, but they did give me 2 ordered pairs. T is -1, -1. Well, -1, -1 is right here. So I'm going to label that T. And then the other point that they gave me was point S, -6, -3. -6, -3 is right here. So I'm going to put point S right here. And I'm going to use my straight edge to connect those 2 points together. And now, just like we did with reflecting over x equals -2, we counted how far to get to the line, and then we go that far on the other side. We're going to do the same thing here with our segment ST. Let's do T first. How many hops to get from T up to the line? How many hops to get from T up to the line? 3. 1, 2, 3. So on the other side, I go 1, 2, 3, and I place my point, and I label that as T prime. What is that ordered pair? What is the ordered pair for T prime? -1, 5. And then we're going to count to get from S up to the line. How many hops from S up to the line? Five. 1, 2, 3, 4, 5. So on the other side, we go 1, 2, 3, 4, 5. Place the point. Label it as S prime. Use the straight edge to connect those 2 points together. We still need the ordered pair for S prime. What is the ordered pair for S prime? Close. Yep, -6, 7. So far, so good? Let's flip the page. Look at page 4. Rule for reflecting across the line y equals x. Y equals x is a diagonal line that starts in the lower left corner and goes up to the upper right corner. Yep. If we reflect across the line y equals x, the point AB becomes BA. So we switch the x and the y. Marker, name, date, and time. You switch the x and the y coordinates. If we are going across the line y equals negative x, this is also a perfectly diagonal line, but it starts in the upper left and goes to the lower right. If we reflect across the line y equals negative x, the point CD becomes negative D, negative C. So you switch and change signs. So you flip the numbers around and you change the signs. All right, let's see if we can do number 6 here. Number 6, we have point M, which is 4, negative 7. Graphed in the xy plane. Find M prime if M is reflected across the y-axis. If we reflect across the y-axis, what stays the same? Y stays the same, and x changes signs, yes. So if x is changing signs and y is staying the same, what would M prime be then? Negative 4, negative 7, yes. If we reflect across the x-axis, now x is the thing staying the same, and y is the thing that changes signs. So going back to point M, x stays the same, y changes signs. What will M prime be? 4, 7. Reflecting across y equals x, this is what we just talked about at the top of this page. We said the point AB becomes BA, so we're going to switch x and y. So instead of 4, negative 7, what would I get if I switch those around? Negative 7, 4 is absolutely correct. If we go across y equals negative x, not only do we switch x and y, we also change signs. So here I've already switched x and y. But I still need to do what to that if it's going to be over y equals negative x? Still need to change the signs. So what will m prime be here then? 7, negative 4, yes. 7, negative 4. Part E, we're going to reflect across the line y equals negative 8. This is a horizontal line. I know it has to be horizontal because it has a y equals, so that means it's going to go through the y-axis. So I go to the y-axis. I find negative 8 on the y-axis. That's right down here. And if it goes through that point, it has to go this way. This is y equals negative 8. Point M is at 4, negative 7. So here's my point M. How far away is point M from that line that we want to reflect over? How many hops away? 1. So I would go the same distance on the other side, so 1 hop away on the other side. So right here would be my point M prime. And where would that ordered pair be? Where is that ordered pair now? 4, negative 9. All right, and then the last one here. We're going to go across the line x equals 1. This is a vertical line because it goes through the x-axis. So I go find 1 on the x-axis. That's right here. I'm going to draw a vertical line through that is dashed. That is x equals 1. And we are going to move point M. So this original black point right here, this is what we are reflecting across that green line. How many hops to get from this black dot M to the green line? 3. 1, 2, 3. So on the other side, I go 1, 2, 3. Put my point down. That would be M prime. Where is that point at? Where did that point end up? This one right here. Negative 2, negative 7 is correct. Negative 2, negative 7. Beautiful. Very nice work. Thank you. All right, let's go look at number 7. Number 7, given the graph to the right, reflect the triangle across the line y equals x. So this line y equals x, as I already mentioned, this is a diagonal line. It starts low on the left and goes to high on the right. This right here is the line y equals x. It goes through the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, where the x's and the y's are the same. It goes through that point. To reflect across that line, we are going to switch X and Y. So where is point G located right now? Negative 4, 4. We're going to switch that to get G prime. So what would G prime be then? If I flip that around, 4, negative 4. So I have a point G prime at 4, negative 4 down here. Then I need the ordered pair for F. What is the ordered pair for where point F is right now? Negative 1, 4. So where would F prime be then? Four, negative 1. So we're going to put a point down at 4, negative 1 right here. There's my F prime. Then I need the ordered pair for point H. Where is point H at right now? Negative 5, 1. So where is H prime at then? 1, negative 5 is correct. 1, negative 5 would be right here. So there's H prime, and then I grab my straight edge and I connect my points to make my reflected triangle. It should look like a fold over this line. All right. Just a little bit more to go at the bottom of the page. Let's look at number 8. Reflect triangle GFH about the line y equals negative x. Y equals negative x is also a diagonal line. But it goes the other way. It starts high on the left and goes low on the right. So y equals negative x looks like this. To do this reflection, we will switch x and y, and we will change the signs. So what is the ordered pair for point G? Where is that at right now? What is that ordered pair?
5, 6.
Negative 5, 6, yes. Negative 5, 6. We need to take that, we need to switch the x and y, and we need to flip the signs. So where would G prime be then? We're going to flip it around, and we will change the signs. Negative 6, 5. The 6 and the 5 switch places. The 6 becomes a negative, the 5 becomes a positive. So negative 6, 5 would be right here. Here's my point G prime. All right, let's do point H next. Where is point H currently? At 2, 1. So where would H prime be? Where would H prime be? Yep, 1, 2, and then we change both of those signs so it becomes -1, -2. Flip them around first and then change their signs. So -1, -2. Right here is my H prime. And then finally, we need to do point F. Where is point F at currently? What is this ordered pair? 4, 5. So where is F prime? -5, -4, yes. -5, -4 is right here. So there's F prime. Then I'm going to use my straight edge to connect those 3 points to make my reflected triangle. I'm going to move my label for H prime just a little bit. There it is. All right, one more graphing problem and then number 10. Number 9 says we're going to reflect across the line x equals -1, which is a vertical line because it goes through the x-axis. So I find -1 on the x-axis, I put down my point, and I draw a vertical line through that point. That is x equals -1. And then we're going to count for these points. Let's do V prime first. How far to get from point V to the line? How many hops? 3. 1, 2, 3. So on the other side, 1, 2, 3. Put my point down for V prime. Where is that ordered pair? -4, -5. Now we're going to do point W. How many hops to get from W to the line? Let's see. 1, 2, 3, 4, 5. So on the other side, we go 1, 2, 3, 4. We're going to have to go 1 hop past the graph to put our point down to get W prime. Where would that put W prime? -6, -1. Yep, -6, -1. And then we need to move point X. How many hops to get X to the line? 3. 1, 2, 3. So on the other side, 1, 2, 3. Put my point down right here for X prime. What is the ordered pair for X prime? What is the ordered pair for X prime? -4, -2, yes. -4, -2. Then we're going to take our straight edge and we're going to connect those points together. to make our reflected triangle. Should look like it has been flipped or folded over that line. All right, last question, number 10. True or false? The orientation of a triangle is preserved, so it stayed going the same direction. W is to the right of point X. Is W prime to the right of X prime? No, then orientation was not preserved. All points are moving the same amount. Did we count the same amount for X that we did for W? No, this is also a no then. Distance of an object from the axis of reflection is preserved. This one is yes. If it was 3 hops away to the right, it'll be 3 hops away to the left for the prime. Sign of X and Y coordinates stays the same. Do the signs stay the same? No, in fact, some of them we switch the signs. Angle measures of the triangle are preserved. Did my angle measures stay the same? Yes, the angle measures stayed the same here. All right, very nicely done. Homework that you got before break is due tomorrow. The front side is about translations, slides, or shifts. That you learned how to do on Thursday and Friday before break. The back side is about reflections, which we learned how to do today. If you need another copy of the homework, it's this very bottom paper right here in the red organizer.